Hello! Hi everybody. Hopefully there you guys had a good little break and were able to get a refill the coffee. And now we're on to video number 2, which is tissues and you can see the where we're moving to. And now we're into a collection of cells, tissues, and this is a fun one. Welcome. This is where the medical evolution begins right here. Okay, and we're starting our journey. So I'm going to share the screen here. Where am I? For some reason it's not. That looks like it's it right there. Perfect. So does anyone here have any questions for me before I begin? I can't see if you have your hand up, but if you just shout out, let me know if you guys have any questions. On the previous video there, we talked about the test. I'll talk about it again if you guys came late there today. The test will open up there this afternoon. It will only be on weeks 1 and 2 material, not chapter 5 or this one here, chapter 6. That will be on the next quiz. Okay. Now the test is only multiple choice. There's around 60 questions, could be 58, 59, I forget now. But they will appear. You will go into Blackboard there this afternoon. I'll send an announcement out there when the test is live. There's no rush at all. It's open for like 6 days, 7 days. It'll close next Tuesday at midnight. Okay, so lots of time to get this done. The only concerns there the first 2 weeks, the question will be randomized and appear one at a time. Okay, so yeah, have some fun with it. Ask as many questions as you can throughout the duration. You'll be able to start the test as you like. Just because, I want to try and be accommodating because, we have busy lives, right? People got 1, 2, 3 jobs, trying to make ends meet. Do the test when you can, okay? Let's go, shall we? This is a kind of a long one as well, so hopefully there we can get this one done sooner than later. Let's move it. We're going to talk about the 4 major types of tissues, okay? We're going to describe their function and their physiology, describe the characteristics, functions, their connective tissue. We're going to look at nervous tissue. We're going to look at all the different layers there for muscle tissue. It's a good one, okay? So there are 4 major types of tissue that in the human body. There's epithelial, okay, connective, nervous, and muscle. Okay, they all look very different, and within those there are many different kinds of epithelial cells that do different jobs, many different kinds of connective tissue. Blood and bone are both connective tissue. They do different purposes. Nervous, nerve cell, muscle, and there's 3 kinds of muscle. We'll get into those ones as well. The study of tissue is called histology. All right, and you'll remember there that tissues are just simply groups of cells that perform a single function. That's it. Liver cell, these kinds of things. Very good. Epithelial tissue. Where is it found? Okay, forms in large continuous sheets to cover the body. Skin, epithelial tissue. Okay, covers the body's outer surface, as well lines a lot of the inner cavities, the mouth, the respiratory tract, reproductive tract, digestive tract, these kinds of things here, okay? Epithelial tissue, what do they do? Protect, absorb, filter, secrete, and transport. The big things there with epithelial tissue there, it's basically a way for things to get from one side to the other side. So epithelial cells tend to be absorbing. They allow things to transverse them, to move through them, okay? Epithelial tissue can take many different forms here. You'll see that it can form continuous sheets like floor tiles, okay? Like there's transitional epithelium there that lines the urinary bladder. And this transitional epithelium there, it has the ability to stretch. So as the bladder fills with urine, these stretch receptors within the epithelial cells get stretched and stretched, and once they get stretched to a certain point, they make a phone call up to the brain and go, yeah, this guy needs to find a toilet soon. That's how it goes. There's undersurface attachment there to what we call a basement membrane, basement membrane, where you'll have epithelial cells stacked on top of each other, and the nutrients goes all the way through some cells all the way up. So there's this basement membrane where all the food comes from, and that's how these cells get fed from underneath. Tend to be avascular, depends on the underlying connective tissue for nourishment. The epithelial tissue is widespread throughout the body, covers organs, lines the body cavities, makes up glands. It always has a free surface to it. And you think, your digestive tract, your respiratory tract, what does that really mean? It just means that there's a hole, right? The air is going down your trachea, through your bronchs. The food is going down your esophagus, through your stomach, and then through your digestive tract there's a hole, right, for the food or the air to pass through. Well, the lining of the hole, okay, is all with epithelial cells so that we can absorb food nutrients. We can absorb oxygen through those, and they will get to the other side. And what's on the other side of the epithelial cells? Blood vessels, there to absorb that food and nutrients, right? So just remember, there's a hole, and we call this a lumen. Okay, a lumen, L-U-M-E-N. It's a hole, okay? And the lining of the lumen there, when you're talking respiratory digestive tract, is epithelial cells, okay? They are made up of tightly packed cells containing little intracellular material, generally lack blood vessels, and readily divide. Skin as well. And they're all nourished by the cells from the underlying connective tissue. Okay. This is a great little slide there. These are the different kinds of epithelial tissue there that I'll ask you about. There's more. There's transitional epithelial. But generally speaking, you'll see there the format. There's squamous epithelial, which are short and flattened. Now you can have simple squamous epithelium, or you can have stratified squamous epithelium. Stratified just means you got one on top of another. Okay? But you'll see there that there's a basement protein or a basement membrane, and that's where all the nutrients are coming from. And these cells here all get fed by this basement membrane. Okay? You can have cuboidal, simple cuboidal. It's cube shaped. You can have stratified cuboidal epithelium. You can have columnar, when this is simple columnar epithelial, columns. You can have stratified columnar, one on top of each other. And this one here, it kind of looks like, you're in the mosh pit at a Green Day concert here. These are what we call pseudo-stratified squamous epithelium, where it looks like they're kind of one on top of each other, but they're not. They all have access to that basement membrane. Okay? Just jumping back here, these epithelial tissue function in protection, secretion, absorption, and excretion, moving things in, moving things out. Oxygen in, carbon dioxide out. Shapes, squamous, cuboidal, columnar. There's transitional as well. Can be simple or stratified. There's that free surface which can be modified to reflect specific functions. There's cilia, microvilli. Okay. Epithelial tissue is found all over the body. Okay, you've got the ovary surface. There's your simple cuboidal. Okay, mouth and skin, stratified squamous. Respiratory tract, pseudo-stratified, okay, squamous epithelium. Pseudo-stratified columnar. We've got air sacs in the lungs, simple squamous. We've got digestive tract, simple columnar, and bladder. There's your transitional. Okay. Simple epithelium, stratified, good stuff there. Glandular epithelia, okay, function there is to secrete, and we have exocrine glands, endocrine glands, okay, and these guys here, they reside, and These glands here are used to excrete chemicals, salt, water, sebum there if you're talking about the hair. Okay. Connective tissue, location, blood under the skin, bone around the organ, function, connecting, support, protection, fat storage, transportation. Oh yeah. The extracellular matrix there of connective tissue, you'll see the whole idea of this fibrin proteins, collagen fibers. You know, that's what connective tissue is. Blood is connective tissue. It's all the connect, support, protect. Connective tissue, the name implies, right? What does it look like? Intracellular matrix there, very abundant, varies from liquid there to hard. Most is well vascularized. The exceptions are tendons, ligaments, and cartilage. The whole idea there that which is easier to repair, bone or cartilage. If you break a bone or you rip cartilage, well, the cartilage there very avascular. Doesn't get a lot of blood supply. So if you rip cartilage, it takes a heck of a lot longer to fix than it does if you break a bone. Crazy enough, eh? Presence and amount of protein fibers vary. You've got collagen fibers, elastin fibers. You've got reticular fibers there. This is just an electron micrograph of what we call a fibroblast. Most common fixed cell type, a large star-shaped cell that secretes fibers. Okay, protein, right? You need that continual source of protein. Okay. Types of connective tissue. There is loose connective tissue, which areolar adipose tissue. Adipose is fat. Okay. Reticular, you can have dense fibrous cartilage. There's a couple different kinds of cartilage. There's hyaline cartilage, fibrocartilage, elastic cartilage, all these different kinds of cartilage. Okay, there's cartilage there in between joints, in your spinal column, those cartilage discs. That's fibrocartilage in there. You've got bone. You need some calcium, blood, and lymph as well. Oh yeah, when we get into the blood and lymph, that's a good. That is a very excellent week. So major cell types, they can be fixed or wandering. Okay, fixed connective tissue, they stay in place there for a long time. Wandering, these guys here can move. Really? How can they move? So types of connective tissue, we're just having a look here. There's dense fibrous. Here we're talking about in between, holding bones there together when we're talking ligaments. Okay, when we get into bone cells, this is what they look like. These are what we call osteocytes, or osteons here. And are bones alive? Most definitely. You'll see there that there's blood, nerve, there's lymph as well, and they're all here. The bones are alive. You have, there's cartilage. Okay. We've got areolar. Tissue down here. We also have, there's your adipose tissue, most easily recognizable as fat. Reticular fibers there when we're talking about the bone marrow. Lots of good stuff here. This is a macrophage that is chomp chomp, Pac-Man eating a bacteria. Okay, I'm just going to zoom out a little bit here. There we go. This is what we call a mast cell. These are large fixed cells, okay, located near blood vessels. They release heparin, which is an anticoagulant, blood thinner, makes the blood watery. And as well, mast cells are famous for producing histamine. Now, histamine, the body will, mast cells, the body will produce histamine when it encounters a foreign agent that it perceives to be dangerous. And millions of people around the world who have allergies, they deal with this there on an annual basis. You know, the whole idea of pollen and, dust that are not dangerous to us as an organism, but the body perceives it to be dangerous. So that when it encounters some pollen or dust, this person there will start to produce histamine. And histamine is a chemical. It gets the nose flowing. The nose starts running, right? Get that mucus out. If the mucus is moving this way, nothing can get in. Eyes start to water. We're moving things, we're excreting things out, getting things out, and that is why we take antihistamines to calm the body down. Okay. Loose connective tissue, here are these areolar, okay, and you'll see forms thin, delicate membranes. Main cell type is what we call a fibroblast. Matrix consists of gel-like ground substance with collagen reticular fibers. Basically binds the skin to the underlying tissue. You know, when you move your hands like this, you ever wonder why your skin just doesn't fly off? Well, because it's bound together with this areolar tissue. It binds the skin to the underlying tissues. Okay. Here's adipose tissue. Here we're talking fat. All right. Love the formatting on Blackboard. And you'll see there it contains adipocytes, which store fat in the cytoplasm found under the skin, between muscles, and in and around kidneys. The whole idea there that what do you think your organs sit on? You need fat. Okay, your organs there, they have these spaces that are just designed for them, and they're completely held into place by fat. Okay, there's actually called the greater omentum, which is a big fat blanket that just holds everything in. Okay. Fibrocartilage, wonderful formatting. Isn't Blackboard great? Tough tissue containing many collagen fibers there, good shock absorbers, found in the intervertebral disc, knees, and pelvic girdle. Okay, different kind of cartilage, right? The kind of cartilage here, not the same kind of cartilage there that is found in between, because these guys here, not only do they have to shock absorb, they have to dissipate that shock and keep it away from the bones there of the spinal column. Bones. Okay, here we're talking about bone tissue. Okay, supports and protects. The bones are great. We deal with that there in a couple weeks. Definitely a great organ system. You know, it's all about protection, support. Bones make blood. Okay, site for blood cell formation, acts like a mineral bank. Calcium, phosphate, these minerals here, we just don't throw them out. Calcium is very important. Mama always said, drink your milk, eat your yogurt, it's good for your teeth and your bones. But what Mama also didn't say is that a muscle or nerve fiber would not fire without calcium present in the body. Okay, so we just don't throw this stuff out. If the blood calcium level starts to get too high, well, then we start dumping calcium onto the bones. If the blood calcium level starts to drop, we start robbing the bones of calcium and throwing calcium back into the blood. You'll see there that your body is always in some type of homeostatic mechanism there when we're talking about calcium. Okay, the same bone can be being built up and degraded at the same time. Okay, two types of bone here. All right, you've got compact bone. You can see it in and around here. And then in towards the middle, the medullary area there, you have what's called spongy bone. Okay, we'll get more into this there when we actually get into bone. That's a whole week under itself. Okay, and it has a wicked blood supply. Okay, bones are most definitely alive. Blood functions there to transport substances throughout the body. Okay, between interior cells, exchanging nutrients, gases, water. Blood moves things from A to B. Composed of formed elements suspended in a liquid there called plasma. Okay, the majority of blood, you know, blood looks like a red liquid, but if we centrifuge it down, you'll see the majority of it there is this yellow ooze. You kind of see it there if you ever let a cut go, this yellow ooze plasma. Okay, but there are lots of other things in blood besides blood. There's white blood cells, there's platelets, there's all these kinds of things. We'll get there. Dissolved oxygen, carbon dioxide, glucose, hormones, all these. The formed elements include RBCs to carry oxygen, WBCs for protection against infection, and platelets there for blood clotting. If you get a cut, right, these platelets just dive on, and then another one dives on, and another one dives on, and eventually there you plug the cut. They use fibrinogen there. It's kind of like this spider web mesh. I'll show you that there in a little bit. Okay, most blood cells are produced by the red bone marrow. Okay, within the bones. The blood has a life expectancy, I think, about 4 months. Okay, blood doesn't have any DNA. RBCs, there's no DNA, there's no mitosis, there's no splitting. After about 3 to 4 months there, the blood gets the chomp chomp. And every part of the RBC that once was gets reuptook and then made into new blood. Okay. Just some shots there of your RBCs. There's your white blood cells, the little guys in there. You'll see the platelets. Okay, perfecto. Just a little summary here of connective tissue. All right, you guys can have a look at this there. Use this as a guide. There might be a question or two that comes from this there. There's your areolar tissue, adipose tissue, reticular connective, dense connective, specialized connective, and then you've got all these ones in here. Okay. Moving on into nervous. Nerve tissue tends to be the easiest to identify. Okay, it kind of looks like a monster there from a 1950s monster movie, right? And the whole idea here that the nervous system is just one way for the body, for the brain to talk to my big toe. The other way there the body can do that is through the endocrine system, hormones, which tends to be very slow, but the effects can be monumental. Nervous, very fast, efficient, short-lived, does the job, goes away. Okay, and that's the whole point there of the nervous system. And the nerve, like if the brain wants to talk to the big toe, it's not just one 2-meter long nerve cell. There's 100 bazillion of them, like almost like railroad tracks, right? And you think about the logicalness of a system like that. If one nerve cell gets damaged, and if the nerve cell is 2 meters, well then the whole nerve cell is dead. But if you have 100 bazillion of them and one of the nerve cells down here gets damaged, well, all these other nerve cells are okay. Okay. Makes up the brain, spinal cord, and nerves. 2 types of nervous cells there. You got neurons and neuroglia. And again, not going into too crazy. It's beyond. We will come back to nervous tissue. You're going to do an assignment on that, but just introduction there. Muscle tissue, there's 3 types of muscle tissue: skeletal, smooth, and cardiac. And you'll see here that we'll start off with skeletal. It is voluntary. I have control over it. It is extremely strong. Just ask Arnold Schwarzenegger. But it's short-lived. I can't lift a dumbbell 500 times. I won't do it. Okay, so skeletal, voluntary, strong, short-lived. This is for performing functions, exercises. Smooth muscle, it's a different kind of muscle. It's involved in body functions, autonomic. The whole idea that after you swallow that banana, you don't see that banana for another 36 hours. But how did it get propelled and moved through the whole body? Well, the whole process of peristalsis, moving things, after you swallow that banana, you can go on YouTube and see people inverted drinking a glass of water, because the peristalsis now is pushing that water up to the stomach if you were inverted. These guys here are kind of like the opposite of skeletal. They are involuntary. I don't have any control over my tummy or how my intestine works. Okay? So it's involuntary. It is not strong. Doesn't have to be. You're just moving food around. Okay? And it lasts a long time. So completely the opposite of skeletal. Involuntary, not strong, lasts a long time. And then we have cardiac, which is a combination of the two. It is involuntary, very strong, very long-lived, I hope, for all of us, right? That's cardiac muscle. And you see the anatomical differences there. There are physiological differences in there. We'll get more into that there when we get into muscle, okay? Tissue repair, regeneration, replacement of tissue via mitosis. You'll remember there for blood, there is no mitosis. It just gets the chomp. Fibrosis, replacement of injured tissue with fibrous connective tissue. Scar. tissue. The whole idea, what is a scar tissue? Keloid scarring. You can see, if you've ever seen Dr. Pimple Popper there, you see people there that they've had some surgery and these keloids have grown. It's this overproduction of scar tissue. Okay. Steps in tissue repair. Okay, the initial cut is there, and you see a blood vessel has been nicked. Okay, there's the wound. Then all of a sudden, the blood starts rushing out, and within the blood there are the platelets, and you'll see there that the body tissue starts to repair itself. And you think there that when you have an infection, like there's swelling, right? It's sore, it's red, it's irritated. All that means is that there's more cells there than there should be. And the more cells are putting pressure on, and that's why it hurts. Because you have all these macrophages, you have all these different dendritic cells that are there cleaning up the mess. Any bacteria that would have got in, they're watching. And you can see them there. The epithelial cells begin to multiply once we're back into a kind of a sterile environment. And then the scab forms. And you can see there, the scab detaches. Good stuff. Membranes there, thin sheets of tissue that cover the surface, line body cavities, surround organs. Classification of membranes. There's epithelial, there's cutaneous. Interesting. Where would you see that one? Cutaneous epithelial, mucous epithelial, serous epithelial. Connective tissue here, we've got synovial, periosteum, perichondrium, meninges, and fascia. And you have a look at there, you'll just have a look there. Epithelial membranes are kind of related there to cavities there from week 1. You'll see that every single organ has its own place. And when you're talking the lungs here, there's a lining that covers the lungs, but there's also a lining there that covers the cavity that the lungs are in. Same with the heart. And you'll see there that the visceral membrane covers the organ. The parietal membrane covers the cavity. And so there's actually a space in between. Yes, it's all about protection. It's an added layer of protection to protect these organs from an infection. Again, your visceral is touching the organ. The parietal membrane is touching the cavity. Okay? And again, you'll see the same shot right here. Okay? Here's just a cross section there. Across. Okay? And you see there's your heart, there's your lungs. This is anterior. This is posterior. How do I know that? Look for things there that are identifiable. That is spinal cord. This is the back. This is posterior. Anterior, the front. Left, right lung. And you'll see there that you zoom in when you're talking these membranes and linings of the organs. You'll see there that the visceral pleura lining the lung, okay, that is lining the organ itself. You have the parietal pleura, which lines the cavity, okay, and it creates a space. And when you're talking the lungs there, the lungs produce a chemical there called surfactant. It's kind of a soapy substance there that keeps everything all nice and tight-knit in there. We'll get to that when we get into respiration. Okay. And mucous membranes line all body cavities that open to the exterior of the body. And again, wherever there's a hole, there's going to be some type of body protection, because outside the hole, bacteria can get in. Okay. You're talking urinary tract infections there. Females there, the urethra is very close there to the outside, so you tend to get more UTIs there, females and males. Digestive tract, respiratory tract, they're all there. You'll see there layers of the wall of the small intestine. Okay, there, just working your way out. And we'll start off with this slide here. There is your lumen, right? Here's your lumen. Okay, so let's go from the lumen inside. So you have those cells on the inside and moving your way out. You'll see there that there's a mucosa. Okay, then you have what's called a submucosa. Okay, So here we're talking mucus, right? Mucus, one of the greatest sources of protection. We breathe in 500,000 bacteria with every single breath, while our lungs are producing lots of mucus. 500,000 bacteria go into our lungs, they get trapped in the mucus, we kick that mucus out through cilia, okay, and eventually get rid of it. Mucus, we need it. So there's your mucosa level, submucosa, and then there's your muscularis. That's the muscle. So when you're talking the small intestine here, the whole idea, that's your smooth muscle, right? Involuntary, no control, very weak, long-lived, and it's pushing that food back and forth again. It's called segmentation, squishing all that food, mixing it all together there for the point of eventual absorption. Okay, that is where we are at. Serous membranes here, they line the ventral body cavities that do not open to the exterior. There's that word pleura. Go back to that lung slide there. Okay, it just shows you there the different membranes that are involved encapsulating these organs. Pericardium, peritoneum. We're going to get more into these as we get into the organ systems. That's all we have there today, people. That one there was a little shorter, a little less time, and I hope there that you guys are okay. Do any of you guys have any questions? I'll be posting these videos immediately after, and probably in sometime there in the next couple of hours, I will post the quiz. Yeah, it's around 60 questions. It is not due today. Do not hand it in today. Do not think you want to do it there today. Don't even, you know what I mean? Don't finish it there. Take your time. These tests there, they can be long and convoluted. This is a journey. Take your time and dig through the PowerPoints. You remember that Control F. You can use Control F. Okay, Control is then the bottom left-hand corner on your computer screen, or sorry, on your keyboard. And if you hit Control and then hit the F button, okay, you can, here, I'll just try it right here just to, oh, sorry, I'm not sharing anymore. Let us share, why is it, oh, there it is. Okay, so let's just go through here, and it will totally help you. Let's just have a look here at, I don't know. Let's go, maybe I'm looking for mucus. Maybe I just want to go muke. Where are all the mukes? Oh, there we go, and you see? That was Control F. This little window popped up. I just typed in whatever I want, and it'll find me them all. Okay, it's even digging through there, digs through. And just to help you guys, because these tests can be hard, and you know, your first test, it's only worth 10%, and you're probably thinking, oh, okay, only 10%. But I purposely kept the first couple of tests at around 10%, because, you know, maybe you haven't been in class, maybe you haven't taken a test in 20 years. As we go past reading week, some of these quizzes, I think the one that's worth the most there is quiz 3 or quiz 4. It's on cardiovascular and blood vessels. It's worth 18%. So they're of worth varying amounts, all right? But don't think that you want to, you don't need to hand it in there today. Of course, you can do whatever you want. It's Canada, it's a free country. But take your time, have some fun with it, and dig for the answers. This is your journey, not mine. Yeah, there's elements there for cheating and these kinds of things here, but ultimately, you know, I want you to be an RN. I want you to be an RPN. Go on and get a master's degree. Go and be a nurse practitioner. You know, do these kinds of things. And if that's your goal, I'm on your side, and here's your chance. Have some fun. That's all we have there for today. If anyone has any questions, I don't see any, but I hope you guys are doing okay, and enjoy your day. We still have summer here for another week. Thanks, guys. Have a great day. I'll post this soon. Take care. Bye.